on showing it, we are going to transition right away into talking about Bottlerocket. So if anyone is using Kubernetes, you have an operating system on all of your nodes, and Bottlerocket is the open source Kubernetes or container native operating system from Amazon. So it's an open source operating system. It allows you to minimize kind of that, what's running on the nodes, and really looks at, if all the workloads are containers, what does an operating system look like for that? So we're going to bring in Curtis and Mikhail. And hello.
Hello, everybody.
Hello,
that was exciting. Thank you so much for that introduction. Yeah, I do want to hit on that if we could just dive right in, or was there another introduction you want to do? Okay, yeah.
I mean, you can tell me what you do first, and here at Amazon, like we have lots of time to look at this at Bottlerocket, and it's gonna be great. But just go ahead and introduce yourselves first.
Okay, go for it, Mikhail.
Sure, I'm Mikhail Shapirov. I'm a partner solutions architect. I'm a container specialist. I work very closely with Curtis, with our partners, consultant partners, and ISVs. With AKS related things, as well as other container infrastructure. Very nice to meet everyone.
Awesome. And I'm Curtis Reese. I'm a principal solutions architect focused on containers NetMod here. Like Mikhail said, we both work on the partner team, and we get to do a lot of really awesome integrations with our AWS partners and all things Kubernetes and containers. And one of the passion plays that I get to be a part of, and Mikhail gets to be a part of, is Bottlerocket. And so, like you had that good introduction as to what Bottlerocket is, but I think I want to make sure we're very clear. It's like when you look at general purpose operating systems that are out there today, the process of managing those, securing them, making them ready to basically receive the workloads and operate in production, there's a lot of process that has to go into that. And some of that process doesn't necessarily have to be there. Like it's just there because that's just the way it's been. We have this general purpose OS, and it comes with everything you could possibly need for any particular workload. And it's very dynamic in that regard. But when we look at running containers and what's actually needed to run the containers themselves, it's not as much as what you would need in just a general purpose OS. And so what we did there is we actually stripped out a lot of the things that aren't necessary to run containers, and really focused and honed the OS on just being laser focused on how do I run a container workload? Does it have the Docker daemon? Does it have containerd? And what else are the things that it might need based on the workloads that are on top of that? And then we took that a step further. Like after we've stripped it down, we took it and we secured it even more. And so when you think about what permissions containers need to run, the way that they get those permissions isn't the same. It's not everything needs privilege mode, everything needs kernel access. And instead, most use cases and most containers they're running don't need access to that. They don't need access to the underlying host file system. And so we've essentially locked that down and made it read-only and put SE Linux policies and other security tools in place to really kind of wall that off. And then when you look at it even further, we decide that, hey, maybe the management constructs for this don't necessarily have to overlap with the orchestration constructs. And so what we actually did is separated those two. So there's a container runtime specifically for your container workloads, and there's a separate runtime that's specifically set up for administration workloads, things that might need elevated permissions and access to the underlying host. So that's really kind of the crux of where we started with this process. And I think those are what some of the cool aspects of the way Bottlerocket works today. But in that, do you have any particular questions that you want to discuss or you want us to go over? Should we talk about the update process? Do you want to go deeper into security?
I mean, I wanted to just point out what you were mentioning. Like, general purpose operating system can be secured. It is a lot of work, and
Absolutely.
And in Bottlerocket, we're really taking a hard line between kernel space and user space, right? Containers run in user space, and that's where the workload should be running, and that's how applications and libraries and everything else is packaged. If you're running these clusters, you should only be using those things inside of this user space. Maybe there's a few that are like eBPF or something like that have lower level interactions, but then in Bottlerocket, you really are taking that hard line between kernel space is management and that is very much locked down, but also separating out that user space into what you're using to manage the node and operating system itself, and what are essentially like user workloads or general purpose workloads on top of the node. So you have further separation on top of that between how that's being split up.
Absolutely. And the reality is there, we went that far because we want to make sure that whatever's running and is exposed to the public internet is as walled off from that host as possible. Like we don't want, we want you working to secure your workloads and make sure those are as hardened as possible so that we're minimizing the risk of potential attackers getting into the actual containers themselves. But if they did happen to get access to those containers, we want to make sure that they don't get access to the underlying host and therefore potentially have a vector to get to other containers that are running on that host itself. So imagine they got into that cluster, they'd have access to basically anything in that cluster. And that's where we want to separate those. And that's also why we took it a step further to make sure that the operating system is read-only. And so if we look at, well, let's look at this view here. So this kind of explains the process for gaining elevated privileges at a high level. And most workloads are going to start at the top of this, where they're just a standard pod or a task. And those, when it comes down to it, get the standard SE Linux policy of container T. This means they don't have access to the underlying host at all. They're basically able to get access through what Kubelet provides and get access to metrics and logging and things like that, but they don't actually have access to the host. For those that need a little bit more privilege, you can go into privilege mode. So within your container specification, you can specify that it's privilege mode, or you can add the specific SE Linux policy, which would be Control T, which would give you a little bit more access to that underlying server. And the direction we'd like you to take here is if you don't need access, don't go that route. If you need access, go down this in one step at a time. If you need access to things like the kernel, say you have to perform some tasks that require kernel level access, use eBPF first and see if you can get that working through that. And in that, you'll have elevated privileges to connect to ePBF. And this is the way Cilium works on Bottlerocket. This is the way other things work on Bottlerocket that need underlying access to the kernel itself. And then if you can't do what you need at that level, then you can go one level below to what we call a bootstrap host or admin container. And these are those containers that run in that secondary space just for admin containers. And these can have elevated privileges using Super T where you can get an actual shell prompt. And so we want to be very careful how you go down this path and make patterns of least privilege. But if, say, you need root level access, maybe you're an ISV provider and you want to do runtime scanning or file access scanning on that underlying host, and you need to get that. If you can't gain access through eBPF, then maybe a host container running your agent with elevated privileges is the way to go. But that should be the only option there. And the way this would look from within your actual YAML files is you would just specify the security context, and then you could specify the specific type. So here in this example, we're asking for system U for the user, specific system R for the role, and then Super T for the actual permissions itself. By adding this in, it's going to override how that container gets privileges, and it's going to automatically provide it Super T. And that's a very powerful access. And so it's really nice that depending upon your workload, very quickly, just from the actual spec for the deployment or the pod itself, you can gain the access you need. Mikhail, is there anything you want to add to that?
Oh, for sure. There are many things that I thought probably our users would like to know about Bottlerocket OS. To start with, what is the practical benefit of it? Given the security, and it's not just security, it's effectively the container optimized OS. It has a very small footprint and it shows itself in the uptime. So effectively, you want to bounce a node in your Kubernetes cluster, for example, or you want to maybe perform an upgrade of the OS itself using the partition mechanism and this transactional data we're talking about. At that point, it becomes very fast and the uptime is increased. And that's one of the reasons. But it also not taking away that level of access to the OS in principle, like, for instance, with Fargate, when you are completely isolated from that. And as you pointed out, a lot of partners, and like Cilium, for example, or like Calico with Tigera, they have a need for eBPF access, and that is still possible. So it sounds like it kind of acts in between those, the best of both worlds. Still, you gain a lot of performance and security improvements, but you have a little bit more invasive access compared to a full isolation from the OS level.
Absolutely.
And bringing in a question here from chat as well, is Bottlerocket focused on startup time? Is that a specific goal of Bottlerocket, or just happens to be, when you strip out an OS and make it run less things, we also get faster startup time?
Well, performance sometimes is not the primary concern, but it's a byproduct of a well-architected framework or a well-architected OS. If the OS is purpose-built for that task, then performance becomes one of the benefits, and is a very fortunate one in our specific case. But I'm sure there was a lot of effort put in just performance improvement as well as hardening and security improvements on Bottlerocket.
Yeah, absolutely. That's 100% correct. And there are a lot of benefits. It's not just the speed of the boot up time, but if we're looking at things like the update process itself is also benefited from the minified operating system and the fact that we've made it somewhat atomic. So in like other container OSs that are out there, things like Flatcar and others, we've decided to make this an atomic operating system. So when you actually install it, you get out of the gates 2 partitions. And this is optional. If you want to build your own variant, you can actually remove this if you don't want to go this route. But for the EKS variant, ECS variant, it comes with 2 partitions. One that's the running partition that has the operating system in it. And when you download a new version of the operating system, it goes to the secondary partition, and it's a full reboot. So once you reboot over to it, it either works and cuts over, or it fails and you go back to the running partition. And so the update process is a very fast process because it's done in those stages. You can start it, have it there waiting until you're ready to actually do that reboot, and then it's a very fast reboot.
Yeah, I think it makes sense to also point out something that you mentioned, like containerd is actually used to run containers, and that one is also an optimized pipeline. Not only your reboot is faster, but also container startup time is faster, so that's increasing the overall uptime of the OS.
Yeah, and I do think it's important to also kind of touch like how the actual update process happens, and I've got that on the screen. And this is something that can be a little bit different for people. If you come from the traditional operating system update process, like you're running yum updates through some kind of configuration management tool and then waiting for all those packages to go through and download. And there's a lot of that risk that comes with that, where if one of those packages fails or a dependency isn't available, you're sitting basically waiting for these updates to go through. But the way we've done this is, like I said, it's an atomic update, but it's handled in waves. And I think the best way to describe waves, because this is kind of tricky for some people, and I know Garrett, Justin, during your initial talk on containers on the couch, like we had an issue with that one. But yeah, this is a stumbling point where it's much more like Android when we do updates, where the project itself releases the new version, but all of the actual installed running operating systems or running versions of it basically go in what we call a wave pattern, where we've decided, based on some kind of cryptographic scenario, which instances will get a new version and when. And we don't do it all at once. And the idea here is we want to roll this out in phases, let you see and test your workloads and make sure that they're working as you could, or the way that they should. And then basically over time, they will all become in sync and running the latest version. Now, there are ways to override this. So you can basically say in your setup, ignore waves. And this gives you a lot of control over saying, like, look, I want to manually control when I get these versions. I want to manually control how they get out there. And so you can tell it to just not listen to that and ignore those waves. But the way that we want you to do this, and I'll let Mikhail kind of cover the update. We want you to try and do this in an automated way first, and then fall back to a manual way if possible. And so Mikhail, if you want to go through this, go for it.
Oh, for sure. So I think it's important to point out why this update process, why we talk about update process from the very beginning when we talk about Bottlerocket. This is the very first question that we get from our customers. Well, yeah, it's a new OS. Do you guys handle OS patching? How exactly is it going to work with a container orchestrator such as EKS or ECS? Do I need to do something manually, or AWS is going to handle all of that for me? And the answer to that is a significantly improved user experience and customer experience when it comes to Bottlerocket, depending on what kind of node groups you're using with, let's say, EKS, whether you're using self-managed node groups or you're using managed node groups, your experience is still going to be very pleasant, hopefully. With the self-managed node groups, we provide a Kubernetes operator, and it's also relevant to mention it in the context of our new offering service, Eks Anywhere, which was launched fairly recently. That Kubernetes operator can take care of detecting the new version of the OS, and we do it both for EKS in the cloud as well as for VMware OVAs for EKSA, and apply those updates. And this transactional wave patterns enables us to do it in an atomic way. In a transactional way, that means that if something goes wrong, we can always roll back to the previous state. In addition to that, that update process, if something happens to the kernel, which the rootfs is marked as read-only, we use DM very effectively to create a checksum on effectively a hash on the state of the kernel, and we can always reboot and get rid of that change and restore the ideal state of the operating system from the golden partition, so to say. So with managed node groups, we support it in a way right now, but we have a new exciting feature coming very soon, which is going to be using Bottlerocket as a first-class citizen with managed node groups. And the experience for the customers is going to be very aligned with the experience with any other general purpose OS, whether it's Amazon Linux or Ubuntu with the managed node groups.
And I wanted to bring in this question too, because you keep mentioning the upgrade process of writing to the other partition, but the operating system is read-only. Can you explain why we describe the operating system as read-only, but at the same time, we're doing in-place upgrades and actually writing to disk an upgrade process?
So yeah, it's a little bit of a misnomer that it's read-only. There are a few read spaces like temp, like /temp is naturally writable. But like to Mikhail's point, we have DM Verity on there. We have a few things in place to prevent certain applications from being able to write to that space that don't have permissions to it. But the rest of the operating system is essentially read-only, with one exception being /etc. /etc is where all the configuration needed for the applications and binaries on the OS, that's where that's basically stored and needs to be writable when you boot it up. And so the way that we actually approach that is it's a temp FS that is written when you boot up the instance. So we have a bunch of helper scripts that go through and will take all the configuration that has been provided through the API to basically build /etc for runtime. And then, after that initial boot up is there, you've got things like the SE/Linux policy and DM Verity in place to make sure that if any changes occur in that particular directory or other directories, it's automatically flagged and it's prevented from being executed, and that system can be flagged for inspection.
And so SE/Linux is protecting that at boot time. To Carl's question here, is SE/Linux also being used for workload to workload, isolation?
I don't have a good answer on that one. Like the policies in place really to separate the workloads from the underlying operating system. But the reality is, if you're setting up your Kubernetes environment properly, you've got your proper namespacing, you've got your proper network policy in place. If they don't have access to the underlying file system, they can't really cross-talk in that regard. I don't want to say it's a perfect world and that's an impossibility, but it's if you've set things up properly, these shouldn't be able to talk to each other. And even if one does have access down through the SE/Linux policy, it shouldn't have access to the other workloads unless you've explicitly given it permissions. Like if you've given it super T, you've basically handed it the keys to the kingdom. So be very careful about how you give those permissions. And then you can also extend these policies. So if you own the system and you want to go through that process, you can extend the SE/Linux policy based on your own configuration to make it match what you need. But just understand that if you go through that process, there are challenges in that, and you're introducing additional risk. So make sure you're doing the right thing.
And that was exactly what I wanted to get to, was the default policies we have are about isolating the operating system and protecting the OS from the workloads. And if you're saying, here, this is a privileged workload now, it does have more permissions, but any other policies you want to add for your workloads are also optional, that you can go in and say, hey, I need more policies because we use SE/Linux between these workloads. That's up to you to manage inside that environment, and Bottlerocket's not going to give you that by default, but SE/Linux being enabled does make sure that SE/Linux is enforced.
Absolutely.
And I don't know if you had another slide. I did want to mention, we've been mentioning Bottlerocket all day, everything is just using Bottlerocket over and over again. Eks Anywhere has it by default. I don't even think we mentioned it, but Carpenter is using Bottlerocket by default. So if you have, if you're using Carpenter for node autoscaling, Bottlerocket is going to be the default node type, and managed node groups will be getting support for Bottlerockets without any additional configuration. You can say, hey, I want to manage node group. Please make the nodes the Bottlerocket OS, and away you'll go without needing anything in addition, right?
Absolutely. And that's the direction we want to keep moving. We want to continue to see Bottlerocket being available as a default option. Maybe not the default option, but basically a option in any of the dropdowns for whatever solution you're using. We want to make it so it's seamless and something that can be used to power your containers no matter where they're running. And so looks like Mikhail wanted to say something in particular, so I'll let him.
Yeah, I think at this point, when we talk about what is the right OS for the orchestrator like EKS, for example, and we have a container optimized OS. So the question is, what would be the reason not to use Bottlerocket compared to it? So that's the kind of feedback that we would like. Why would you go down the path of using a general purpose OS when you could use Bottlerocket with the latest kernel, with the eBPF features, or any features basically enabled by the kernel, and secure by default, within your distribution, gaining the benefits of performance and security, obviously, as well.
Yeah, it begs that question of really making sure that when you're architecting your workloads, really understanding what are the actual needs that workload needs underneath. Does it need root level access? Does it need privileged access? If it doesn't, then you can remove some of the undifferentiated heavy lifting around management, around updates, around hardening, that may not be necessary for that particular workload. And from my experience, like the vast majority of workloads that I've seen from customers don't actually require that level of permission. So by making that the default, you're getting a little bit more of a benefit out of the gates, and you're getting the performance benefit for your workloads as well. But yeah, I think it's important to call out the managed node groups, like that is coming, and hopefully soon. But the idea there is a lot of customers and a lot of even consulting partners, when they're implementing workloads for customers in particular, they want to do this in as much of a managed state as possible. Like they want to take that heavy lifting off of them. And by having this as a default option there, we're giving you an additional chance to alleviate the management of those underlying nodes, but not necessarily abstracting as far away as like Fargate, for instance. So you're getting that kind of the balance between the two there. And so if you need a little bit more access, you need a little bit more performance, or you need something off that underlying host, you have that flexibility to have that while reducing some of the management overhead. And that update process, just so we're clear on that update process for managed node groups, this is going to be largely a manual process where we'll go through and you basically flag when you want that update to happen. And even when we consider the automated process, depending upon how you've spun this up, you can use EKS-CTL, Terraform, CloudFormation, you got the managed node group option itself. When you think about how that's provisioning it from an infrastructure as code perspective in AWS, there's going to be a launch configuration and an autoscale policy probably tied to that. And it's going to have a specific version of that Bottlerocket AMI in there from when you initially spun it up. And so we want you to kind of consider that in concert with that automation, where the operator will keep it up to date and make sure that the nodes you have are running the latest. But at some point, you're going to have to go through a process and perform an update to make sure that launch config is using that latest version. And so I don't want to make it seem like it's this magic thing that does everything, because as soon as we flip that page, people go, aha, I caught you. I want that to be very clear. There's one little check there that you have to make sure is ticked. But it aligns with the rest of the processes you're probably doing today. Node group replacement at regular intervals, making sure you're always on that latest version. It's just, we've added one level of automation on top of that to help simplify those processes a little bit more.
For sure. I mean, and I can add to that when you say it's a manual process, the part that is manual is just your intention to upgrade to the next version per cluster. So that intention is manual, but also it gives a sense of security, because let's say I'm running mission critical workloads in my production cluster, and all of a sudden decides that there's a new version of Bottlerocket and let's swap it out. So a lot of customers prefer to have this control, so they know exactly when it happens. And as we observed with the operator, we also have a mode when you have to explicitly show your intention to upgrade, or it can do it in the background, and customers start with the semi-manual process of explicitly calling it out, and then when they give it a shot to do it on the background, they enable that mode and just forget about it. And they know that the Bottlerocket OS is always the latest, and our cadence is 6 weeks. We release it effectively every 6 weeks, and it impacts both EKS, AMIs, or EKSA.
And the operator for upgrades is Kubernetes, like you're mentioning auto-scaling groups, if I have a launch template, but even outside of AWS, the operator still works if you have a cluster. I saw one here for Eks Anywhere, where you can run the update operator inside an Eks Anywhere cluster, and there's nothing specific there that requires AWS to do those upgrades on the OS, right? Because it's a CRD with a controller that looks at those operating systems and says, okay, we need to reboot these in a scheduled manner, right?
Yeah, it's basically going to communicate with the API that's running on each of those nodes. And so basically it's going to say, is there a new version available? If so, stage it. Once we get that flag saying that it's staged and ready to go, then we go through and trigger the reboot process. And so it's all handling that locally on those environments. And so it doesn't have to be running in EKS in the cloud, but it can be running in Eks Anywhere. It can be running in even ECS, and it's going to go through that process. And as we continue to expand the project to ensure that it works on other environments and other providers, that process should be the same. And if you look at what we've done, where we've moved to the Eks Anywhere implementation, that implementation is based off of VMware. And it's really one of the first steps we've taken in stripping out the AWS specific portions of that variant to go in that direction. So at one point, the next step will be to make it so it runs on other operating systems and bare metal, or not other operating systems, but bare metal and other providers as well.
Yeah, I think it's a great point that it is an open source operating system. Basically, there is nothing specific to AWS that, inside that operating. You can use it with self-managed Kubernetes. You can use it to just run Docker images on your laptop as well, or in a VM. We do accept PRs. We do encourage participation from the open source community, and I'm looking for your feedback.
Yeah, I would say that adds one last point of clarity that I think should be provided. As a project and what Bottlerocket actually is, underneath, like when you look at what its core purpose is, it is a host OS builder. So it's the tools and the SDK that allows you to build the actual operating system itself. The variants are those versions that include the specific config. So if we look at it from a project perspective, it's really designed based on open source tools to be able to build Bottlerocket variants that can run wherever you need them. We've taken the time to go through and provision variants for EKS, ECS, and now VMware for Eks Anywhere, and we're going to continue that process. And if anyone wants to participate and help, by all means, you're welcome to join the project. You're welcome to submit issues. You're welcome to participate with PRs. I have a talk coming up at reInvent that me and Sam are going to give. Sam's one of the engineers on the project. We're going to give a chalk talk at reInvent on how to participate in the project and get started. And so we're always welcome to support and feedback from the community. And if anybody wants to get engaged, by all means, ping us on Slack or on the developer Slack, ping us on Twitter, or participate through the project itself.
That's awesome. So thank you, Curtis, Mikhail, for coming. We're going to take a quick break before our next section on IPv6. And if anyone has comments, go ahead and drop them in Twitch chat. And thank you. We'll hopefully see you both at reInvent.
Awesome. Thanks, everyone. We really appreciate the time.